Okay, I'd like to welcome everybody to session C06, Informing Benchmarks on Cloud Systems by Lester. And Lester, you're free to go.
Thank you, Bruce. Welcome, everybody. And I had pre-recorded the session last night, and then after I recorded it, some new things happened. So at the end of the recording here, I'm going to stop and add in some updates on some benchmarks I ran last night after I did this recording. But let me just dive right in, and I'm going to start playing my video here. Hi, I'm Lester Knutsen from Advanced DataTools, and welcome to my presentation on Informix benchmarks on the cloud. I'm going to share with you some stories about the testing I've been doing as I've been moving our training servers to the cloud over the last couple of months, and share with you some of the results of that. Okay, let's dive right in. I've been working with Informix since 1983. I guess you could call me an old timer at this. Informix is about all I do. And I want to talk about doing benchmarks in the cloud, what I've been doing the last several months here. So this is sort of the agenda of what I'm going to cover. We'll talk about what the cloud is, about benchmarks and the tools I used. And my basic requirement was to move our training servers to a cloud service. We decided with COVID and everything else that we don't need the office space that we had. We'd actually planned this a long time ago before COVID, but that precipitated it. And so I needed a new place to keep our servers. I'm also going to talk about some experiences with customers that have been on the cloud. I've done several migrations last year and the year before with customers moving to the cloud, and some observations. And then I'm going to share with you the benchmark results. And I think the most important thing is the cost benefit learnings, and then some performance tuning recommendations. So let's start out with what is the cloud. The cloud is somebody else's computer. That means you're moving your stuff to somebody else's computer, and your stuff could be anywhere. The CPU, RAM, instead of being in one nice box, are all over the place. And this is what's frightening is you could have RAM here and here and here, and they could be on different physical machines. You don't know it. And all you know, it's on someone else's computer. And the connection between all these pieces can become the bottleneck, as you're going to see. Now, what I used, and a lot of you know us from doing the Fastest Informix DBA contest, I've developed a series of benchmarks over the years that I can reuse. Every time Informix comes out with a new version, I run the benchmarks on it. Thankfully, that's always been faster or as fast. I've also done a very similar series to this on virtual machines several years ago, and there's a past webcast on that. And one of the key things I found in the virtual machine environment, I'd run the same benchmark 100 times, and I'd get a 22% difference in the results. That was a variance I saw. And I'm seeing the same variance in the cloud, just like that. Third thing I'm going to talk about is old friend of ours from Informix did a webcast earlier this year that I thought was great and a good source of information. Then I'll talk about the tools that we used, Benchmark SQL, and the Unix Flexible I/O Tester. So first, the Fastest DBA contest. Two benchmarks have come out of this. One is a batch billing job that we did in 09 and 010. That basically was take a job, and the first time I ran it, it took 40 hours to run, and let's get it to run in a few minutes. Under a minute is the goal. And folks were able to do that in the contest. When I use it in the advanced class I teach, and it runs initially in about 15, 20 minutes in that class, and we get it down to under a minute at the end there. The second part of that is the benchmark SQL, which is an OLTP benchmark that I'll talk about in just a minute. The other bit of background was Tom Roeger. See if you recognize him in that picture there. He did a webcast in April that I really liked. And if you look very carefully at that slide, now he's with a competitor, but that's an Informix billboard. And he talked about Informix in this presentation and how Informix used to be sort of the king of benchmarking back in the 90s. One of the nice things about this presentation, I'd really recommend you go do it. He does compare AWS, Azure, and Google Cloud. I originally planned to do it. I have an Azure account. I've done some testing on it, but just because of time, I decided to focus on AWS. But he covers it really well if you want to take a look at the three of them and the differences. And how they approach them. The third part is Benchmark SQL, and this is an open source benchmark tool I use. It's interesting, in Tom's presentation, he talks about HammerDB, which is another open source benchmarking tool that is used, that they use in their benchmarks, very similar to this. This is just a screenshot of me running it on one of my machines where I've got 1,000 users, and a user is a terminal, so I've got 1,000 terminals connecting, and I'm doing 110,000 transactions per minute. So this is the basis, the back-end database for a lot of my testing. The other piece of testing that I've used a lot in the last couple of years is the flexible I/O tester. That comes with most Linux distributions. If it's not installed, it's a simple yum install to install it. And here's the source of the documentation. You can Google it. You can find out a lot about it. You do a yum install FIO, you'll get it on most systems. And this is a script I use. It tests the sequential write, the random write, and then I do a read-write test. And I'm going to show you the numbers on different disk configurations in the cloud and my own SSD drives in just a minute. So what was I trying to do? These were my training servers. If you've been to one of my classes, we had 8 servers. At one time, some of them were in a computer room, and then we had some here in the classroom when people would come and attend in person. Here I have them all lined up on a table for one of my last classes where everybody was virtual. And wanted to move these 8 servers or replace them with cloud servers for the future, since we moved out of our office space. And so that was the goal, was to find out how can I get the same performance? And more importantly, how can I get the same cost performance? Because if I had to spend 3 or 4 times as much getting the same performance, it wasn't worth it to me. To do it. It's got to be a reasonable priced performance. And we're going to talk a little bit about the cost price performance. The key requirements was to be able to measure performance. And this is I think the hardest one is repeatable results. Nothing is worse than doing a benchmark and having 2 students on 2 machines, and you say go, and one finishes in 5 minutes and the other takes 8 minutes, and they're both doing the same thing. It's got to be constant. And with our training servers here, we had an average of less than 1% difference in times when we would run things over and over again. And I would run the benchmark I'm going to run 100 times on these machines all the time. Every time there's a new release, and the difference between each run, this is running the same thing 100 times, was less than 1%. And that to me is the key requirement, is repeatable, constant results. It also has to be cost effective. If it was going to cost me a lot more, I was not going to do it. Now, I knew, and from working with clients, I expected a disk I/O bottleneck. One of the migrations I helped a client with about 2 years ago, we were moving a huge amount of data and turning on mirroring. And I did the test in my office on the same size DB spaces, and it took about 15 minutes. 24 hours later in the cloud, we were not done. And that was sort of the big wake-up call. What is the bottleneck here? And I'm going to talk a bit about the I/O bottleneck in cloud servers. I'm also very concerned about the performance variance because, as my graphics show, your CPU and RAM and data could be anywhere. You don't know what else you're sharing that CPU with. And so there is a variance on this. On VM systems, I found it to be about 21, 22%. Here on the cloud, it's about the same time, the same percent. There is a variance there. And that's something I haven't figured out how to really solve. The other problem is the unknown real cost. I had a friend who told me that he moved some servers to the cloud and then suddenly got a bill, and the bill was way more than he anticipated. That happened to me last month when I got my September bill. I had to do a double take and say, what was going on here? And again, there's some unknown costs. You can sit there and do cost planning because you pay for what you use. If you accidentally use more than you thought you were using, or, and this can be the problem, if you leave something on you thought you should have turned off, you're going to pay for it. And so these were the kinds of problems I knew that I was going to face in moving to the cloud. Now, I'm going to talk about Amazon, and over the last 2 months, I've built 12 different instances with varying configurations on Amazon. I've been really pleased with the service. I've taught one class. We had 8 servers for the class. It worked out very well. I don't think the students noticed the difference between having it in my class, in my office, versus having it in the cloud. And the other thing I just want to note is Amazon has their own version of Linux and also Red Hat. I've ended up using Red Hat, but I've tried both versions, Amazon Linux and Red Hat. Amazon Linux works fine with Informix. Red Hat has some more features that I like and expect. One is it has a server install that I could never quite figure out how to get quite the same server installed with Amazon, even though all the parts ended up being there that I did. So they both work. I'm going to keep using Red Hat Linux. So this is what happens when you fire up Amazon and look at your servers running in the cloud. This is the dashboard you get. It shows you your servers you're running, the type of instance, and each one of these types is a different configuration. So here I'm trying several different configurations to see what would happen. Now, I wanted to focus on 8 CPUs because that's what I had in my Lenovo training centers that we used. They were 8 CPU machines. And there is an overwhelming number of choices. And they all have a different price. They all have different amounts of memory. And they have different types of storage you can use. And this is a bit overwhelming to go through this and try and figure out what works best. And I'll come to that in a little bit. The other real overwhelming choice is on disk drives. I wanted SSD disk drives because that was what I was using in my training servers. I wanted fast reliability of SSD disk drives. And there are basically 2 types of SSDs that Amazon has: general purpose SSDs and provisioned IOP SSDs. The provisioned IOP SSDs have a faster throughput, and they go up to 64,000 IOPS per second, whereas the general purpose only go up to 16,000. The provisioned IOPS SSDs are also more expensive. That was my surprise bill. Was I had a couple of these and I'd shut down the machine, and but I hadn't turned off the disk drives, and so even though the machines were shut down, I was still getting billed for the disk drives because I had not freed them up. So here's sort of a quick look at the cost of these servers I was looking at, because cost is important, and to me, you want to look at the cost per transaction. My baseline server is what I had in the office before. It's a Lenovo TS150, great machine, really liked it. I ran CentOS 7. It had 8 CPUs, only 16 gigs of memory, and that was never really a problem. It had an SSD drive, and the monthly cost, and I took everything and converted it to monthly cost because that's the easiest way to do it in Amazon speak, is I took the price of the hardware, divided it by 3 years, was about $33. And we could have moved it out to a rack space for about $200 a server. So that's how I came up with $233. You could nitpick with that a little bit, but I think that's a fair cost for what it would have cost me to take those servers and move them to a rack space and keep them. Now, on the Amazon servers, they go from 270. I did look at some of the smaller ones just because, and these actually worked fine for the regular DBA class. They just won't work for the performance tune class. Up to almost 450 for the bigger servers. Anyway, this is sort of the range of price. Now, the Amazon does not include disk drives, does not include any disk cost, whereas my $233 does include an SSD drive. Now, the cost of disk is where it gets interesting. And here are just some of the disk, and I'm estimating the monthly cost. The high IOPS disk would have cost me $1,590 for 2 of them. And you'll see I have performance breakdowns. This is the bottleneck, the number of IOPS I can get on a disk. It really becomes the bottlenecks. So the real cost savings of the cloud is when you don't need something, you turn it off. So I could do a class, turn it off, and if I remember to get rid of all the disk drives, it doesn't cost me anything. Whereas if I had kept my servers and put them out in a rack space at the end of the class, I'm still going to be paying, even if I'm not teaching a class then. The second real benefit is it's very easy to upgrade and downgrade your machines. And I'm going to take a minute and show you how that works. But the key thing is to monitor your costs, because disk costs in particular don't stop. You can stop the machine, but the disk are still going to be charged unless you downgrade them to something that doesn't cost anything, or cost minimal, because you're still taking up that space in the cloud. So let me show you a little bit demo on upgrading and downgrading. So let's take a look at some of the monitoring features of Amazon Cloud. On the left, I'm logged into my account, and I'm looking at Tiger One, which is the machine I'll be showing you some benchmarks on. And lo and behold, notice right here it says under provisioned, and it actually gives you some recommendations on options based on your workload, what I could upgrade it to. So it says I could go to basically 50 cents, 51 cents an hour is the kind of machine I need for it. But let's go back and look at the monitoring. So I'm opening up the monitoring window, and since I've been running a benchmark for over a day, let's look at the last day. As you can see, I've kept the CPU only at about 33% busy. And it says no I/O here, but I'm going to show you I/O in just a minute. So I tend to ignore what it says here for disk I/O. But the point I wanted to show you here is it does say that the CPU's been about 33% busy, which is what I look for on database systems. I think that's a good number. Now let's drill into the storage. And I have two disks attached, and the second disk is the database disk. So let's open that up. And here I'm looking at the last 24 hours. And you can just see that I'm hitting, and this is the key one, the write throughput ops per second and the read throughput ops per second. This is the limit, and it's basically where you hit the limit of the number of ops per second that you have bought. And as you can see, the benchmark I've been doing is a very write intensive benchmark, and it's just been hammering the disk. And this is the point right here where it stopped. And I finished the benchmark. Now I want to show you one other thing. Now what I'd like to show you is what I think is the beauty of the cloud, is how easy it is to change the type of instance and the characteristics of it. Here I've got a machine called Tiger 2. It stopped. And I'm going to go in and say, let's change the instant type. So now I can upgrade or downgrade what I want for that instance. And as soon as I hit apply, it will take effect. Let's upgrade it just a little bit. Hit apply. I got to remember to go downgrade it. You can also do the same thing with the storage. I'm going to come down here. Let's pick the database disk, and I'm going to go to the action and say modify volume. And right now I'm on a general purpose disk 2. I'm going to upgrade it to a high performance IOP1, and I'm going to keep the size. Well, no, let's try there. I want one where I can specify the IOPS. So let's say I want to up the IOPS. I can just put the IOPS I want in there. And I've just upgraded my machine. I can also downgrade it when I'm done. And that I think is the beauty of the cloud, is you can change your configuration very easily as you go through it. Okay, so let's take a look at the Unix Flexible I/O Tester. I've got two windows up. On the left, I'm on Tiger 1, which is on the AWS cloud, and the right window is on my machine here in my office, sitting right behind me, called Tiger 6. That's been my baseline original training machine. And I just ran the script I showed you to run the test. And as you can see that on the left, it's coming up for the last run, which is the random read and write with about 1,200 kbi per second. On the right, the same script, and this is also on SSD drives, is coming up with 9,285 kb per second. So it's almost 8 times faster than the cloud server. Now let's take a look at my 100 run benchmark. And again, on the left is Tiger 1 on AWS. On the right is my local machine. And I started this on the left on October 3rd at 2 a.m. In the morning. And it finished October 5th just this afternoon. I was hoping to get the results into this presentation. I haven't because it just finished. On my local machine on the right, which is my baseline machine, it finished on the 4th in the middle of the night. And so that's sort of a apples to apples comparison of running the same thing. On the left, this is actually the first run of 100 I've been able to do on the Amazon cloud. Okay, so let's take a look at the performance. And I started out, my original goal was to run the same benchmark 100 times in each one of these machines. And here are the different machines. It didn't work. As you can see, this first machine, Tiger 1, when I first ran it, I ran it for 192 hours and then gave up. It had only done 37 runs. My baseline, Tiger 6, will do 100 runs in 27 hours. That was my baseline. I cut the script down just to do 20 runs so I could get some numbers here. And then what I did is I said, okay, based on the time it took, how many runs could I do in a month? And so if I was just going to run the same benchmark over and over again for a month, and I use that over and over again because I have the cost for a month. I could do 62,000 runs on my local machine. And I can only do 37,000 on the largest, most expensive Amazon cloud machine. So that gives you an idea of it. Now, what gets really interesting is when you look at the cost between this and this is huge, the difference between this. And it makes this look very attractive. If you can live with that many runs per month, that performance, that is very attractive when you look at the cost compared to that. Here's with the cost thrown in. And this is the cost per run. I basically take the number of runs, the cost of the machine, the cost of the disk, and say how much does it cost per run. And again, you can see that this is about a 1.3 cents per run. The one that did a lot is 3 cents a run, and that adds up in terms of cost. This would cost me $1,265 a month. This only cost me $294 a month, and I'm getting good average. Now, compare that to my baseline machine. It's none of them are as good as my baseline machine. And that's what was very disappointing to me. So, what can you do to improve performance? The first thing I've noticed over and over again is direct IO doesn't seem to work well on any of the cloud servers. I've done this on Azure, on Amazon, and on IBM's cloud. And basically, I've found you're better off turning off direct IO. Even had a client I was working with that was replicating from an in-house machine with direct IO on to an IBM cloud, and it worked better to turn direct IO off on the cloud machine. They kept it on the in-house machine, but off on the cloud machine. And I don't know why that is. I'd love to dive into that a little bit. The second thing I've found is Informix mirroring improves the performance quite a bit, because if you're limited by IOPS and you have your data on 2 disks, Informix is going to split the reads, and most workloads are 75% reads. My workload here is 90% writes, so it's not a true workload. Most workloads are 75% reads. And so having Informix mirroring means you can go with 2 disks of, let's say, 3,000 IOPS and get the same performance of one more expensive disk of 6,000 IOPS. And so that is, I think, a good idea. The third thing I found is to separate your disk out. Don't put everything on one big disk, because that could become a bottleneck, and you need to play with the numbers. But a separate disk for your logs, which are going to be writes, a separate disk for your temp, which is where most of your IO probably is going to go, and then a separate disk for data and indexes. You want to spread the IO ops around and balance them out. And this is actually, I think, more important in the cloud, because remember, the IOPS is what's limiting you. And so if you take your data, instead of having it all on one big disk, spreading it around, you will probably get better performance with less IOPS per disk. Now, how do you estimate your IOPS? If you Google Amazon, they've got a very specific formula for SQL Server, which I have here. And basically, you take the disk reads plus disk writes, and that gives you the IOPS, and divide that by the number of seconds. That will give you the IOPS. You want to take the bytes per read and the bytes per write and divide that by seconds, and that will give you the throughput. So those are the key numbers you need to figure out on how to calculate that for your machine. Now, you can do that from onstat-p. Disk reads is right here. Disk writes is right here. And you take those numbers and you calculate how long has that number up for. This server's been up for 5 days. Is that number really for 5 days? If so, I have a little worksheet here that I use. Is I take the 5 days, convert it to minutes. I take, this is a cut and paste, so 87, 7, 5, up. I just cut and paste that here. If any of you have been in my training classes, you've seen this worksheet, because we do this as an exercise. And I figure out the KB per minute. And what I do then, this is something new I've added, is I take the disk reads and disk writes and figure out how many IOPS I have per minute. Now, this server had been up for 5 days, but had it been busy all 5 days? This is what's really important. You want to take this for your peak times. And let me bring up this other worksheet. Okay, here we go. So that was really, even though it was up for 5 days, it was a 27-hour benchmark. So I changed the time here and said, let's calculate that 100 runs of my benchmark for 27 hours. And let's calculate the disk reads and disk writes. And what I really want is 24,000 IOPS per second for my system. Again, for your system, take these numbers from onstat-p, time it for a peak time, like pick, the busiest 2 days of the month and time it. Do an onstat-z to clear the numbers out before you time it, and then time it for that period of time. And take the disk reads and the disk writes, and that will be an easy way to calculate your IOPS. So that is my benchmark. I was going to show you one other thing. This is, if you want to see what my 100 run benchmark is. So these are the details I run it over and over again. After the first run, it's the same run over and over again 100 times. And as you can see, most of the AWS machines stopped. The only one that kept going is my Tiger 6 all the way to the end. I was really disappointed in that. I was hoping to compare numbers. And then I have sort of, this is the totals at the end with some cost numbers there. So calculate your IOPS, and you can do that with onstat-p over a key period of time. And that will tell you what you need for the cloud. Now, questions. If you have any, I've pre-recorded this, so hopefully I've been able to answer questions in the chat. Email me if you have any questions, and I'm going to stick around in the chat and see if I can answer any too. I want to do a plug. Art and I are teaching the advanced Informix performance tuning class. We're going to hold this on our new AWS servers in the cloud. It's going to be fun. This is 4 days of benchmarking. You will run these benchmarks. And my goal in this class is for you to make a change, see the results, make a change, see the results. We'll do the batch, and we'll do, I think we do 500 users. We could do 1,000 if we can get the performance. So we'll do 500 users OLTP. With that, thank you guys. Enjoy the rest of the conference.
Thank you, Lester.
Hey, so I just wanted to add an update. Can you hear me okay, Bruce?
Yes.
Okay. So you saw that last night when I recorded this, Amazon said, hey, here's a recommended system for you. I went out and tried that last night, and it actually works. I think one of the problems had been was I had not, Amazon needs about a month's worth of data before they'll come up with recommendations. And that I just got it last night. So I tried it, the recommendation they came up with, and it worked much better. It's still not as fast as my local system, but it did work much better. So that was my update, and stay posted. This is one of those things I'll probably do again and again because I've got a bunch of servers in the cloud now that I'm just going to keep running tests on. So that's it. Thank you guys for attending. Holler if you have any questions.
Thank you, Lester.